block diagonal matrix. This concept may help you in doing some questions. Block diagonal matrix. What is meant by block is a matrix is also called as a block. Diagonal block, you know diagonal matrix. Diagonal matrix means principal diagonal entries will be there, remaining all zeros. Now diagonally you are having blocks. Then it is what is called block diagonal matrix. So, for example, for this, a matrix like 1 1 0 0, 1 1 0 0, 0 0 2 3, 0 0 4 5. This matrix is not diagonal matrix. Is it a diagonal matrix? Is this a diagonal matrix?
No, ma'am.
No, madam.
No, because principal diagonal elements are there. Remaining should be zeros, but they are not zeros. So this is not a diagonal matrix, but it is a block diagonal matrix. But it is a block diagonal matrix. That is, diagonally you are having blocks. What are the blocks you are having? This is in the form A 0 0 B. What is A here? 1 1 1 1.
1 1
What is B? 2 3 4 5.
2 3 4.
5. That is, you are having matrices in the block. Here one matrix is there. Here one matrix is there. Diagonally you are having blocks A, B, remaining all zeros. So diagonally if you are having matrices, then such a matrix is what is called a block diagonal matrix. So if by chance, if the matrix is given in this form, how to find out trace of the matrix, how to find determinant of the matrix, how to find the eigenvalues of this matrix. There are shortcuts that we are going to learn now. Then there is an addition called direct addition, direct sum. It is denoted like this. How it is defined is, if A is a matrix, Aij, M by N, B is a matrix. Again, any order it can be, some K by L, then A direct sum B will be a matrix of order M plus K into N plus L. Row number adding, number of columns, sum. And the matrix is defined as, this is the sum. How the sum is defined is, arrange A and B diagonally, remaining zeros. This is what is called direct sum. You have studied direct sum of subspaces in your courses, direct sum. So that direct sum application for matrices is this. So we are going to arrange matrices diagonally, remaining all zeros. Okay, this is what is called as the direct sum of two matrices. You can extend it to 3 also. What is the difference between ordinary sum and direct sum? You know that ordinary matrix sum is defined only when A and B are of same order, same type, same order. Both may be rectangular, both may be square, but they should be of same order. You cannot add one square matrix and one rectangle matrix in ordinary addition. But in direct sum, you can add any type of matrix. It may be square, it may be rectangle. They may be different orders also. But this one, and what is the order of the resulting matrix? Number of rows plus number of rows, number of columns plus number of columns. This is what is called block diagonal matrix. It is also called direct sum. I'll show you. This can be used for any number. Suppose C is there. What is there in C? A, B, C will arrange. Remaining all 0. So, for example, if I take A is equal to one rectangle matrix, I will take for your sake. And B, I will take it as a square matrix. This is 2 by 3. This is 2 by 2. In matrix addition, we cannot add. But here we can have A direct sum. What is A direct sum is? A direct sum. How many rows, how many columns you will get is 2 plus 2, 4, 3 plus 2, 5. 4 rows, 5 columns you will get. So first, how it is defined? A, 0, 0, B. Direct sum. So how do we write this? First write A, 1, 2, 3. What is that? Minus 2, 4, 5. Is it so? Minus 4, 5. Then, how many rows should be there? 4 rows. 2 rows completed. Remaining 2 rows should be 0. Because 4 rows you should have. 2 rows got completed. Remaining 2 you will get. And here, how many columns? 5 columns. 3 columns are marked. 2 more columns you will get. Five columns completed, 4 rows completed. You can write in the remaining place B matrix. So write the matrices blockly along with the block remaining 0. Mali cheptunanu. A 2 by 3, B 2 by 2. So resulting matrix will have the order 2 plus 2, 4, 3 plus 2, 5. 4 rows undali, 5 columns undali. First write your matrix A. So matrix A is occupying 2 rows already. Only 4 rows. So remaining 2 rows you have to take it as. Then how many columns? 5 columns. 3 columns are defined. So 2 more columns you should have. So 0, 0, 0, 0. Then this block. A and B in the block remaining. Okay? This is the requirement. Is it okay for all of you? Next question comes, what is B plus A? Is A plus B equal to B plus A? Question mark. You know that in ordinary addition, A plus B is A plus B plus A in ordinary. But it is not ordinary, direct. So, A plus B, B plus A are different. A plus B means first you have to write A, then B. If it is B plus A, B 0, 0, 0. What will be this? What is the order? B, same. B is of order 2 plus 2, 4, 2 plus 3, 5. Order will be the same. 4 by 5 matrix. But are they equal? Let us see. What is B means? 1, 1, 1, 1. Okay. 4 by 4 matrix. So 0, 0, 0. Next here. How many columns? 5 columns. 2 columns over. Remaining 3 columns. Here we have to range A. What is A matrix? 1, 2, 3, minus 2, 4, 5. This is A. B plus A. This is A plus A. You can see orders are equal, but matrices are not equal. Because we had ones here. This matrix is here. So this when are 2 matrices equal? Every element here should be equal to every element there. Here we are having 1, 2, 3. Here we are having 1, 1, 0. They are not equal. So A plus B is not equal to B plus C. Very important. Generally, A plus B equal to B plus A. B direct sum A is not equal to this. You may be given among options. Which of the following are true? A plus B equal to B plus A. A direct sum B equal to B direct sum A. So you may think it is plus and you may write it is true, which is not correct. So very interesting point is A direct sum B is not equal to B direct sum A. Very important. but A plus B is, it is ordinary addition, okay. But this direct sum is not abelian. Very interesting. Next, what is the advantage of this direct sum? So when the square matrices are there, if A and B are square matrices, then we can define what is trace. 0, 0B. If you call this as some DH, then trace of H is equal to trace A plus trace. Det H is equal to det A into det B. Then eigenvalues of H, characteristic equation of H is equal to characteristic polynomial of H is characteristic polynomial of A into characteristic polynomial of B. What is in the characteristic polynomial? Determinant A minus lambda I, B minus its characteristic polynomial, some ui. This will be the characteristic polynomial. So what will be the characteristic equation? Determinant A minus H I into determinant B minus mu I equal to C. Because polynomial means there. What is the equation, characteristic equation? If you equate it to 0, polynomial, when you equate it to 0, it is called equation. Then what will be the eigenvalues of H? Are eigen lambda 1, lambda 2, lambda n. Then B is mu 1, mu 2, mu m. They need not be of same order. What are lambdas and mu's? Eigenvalues of A. And mu 1 to mu m, they are eigenvalues of eigenvalues of. Okay. So how to get eigenvalues of big matrices? If we are able to identify that, there are very big matrices like this, easily you can get the eigenvalues. For example, trace, find trace, comma det, comma eigenvalues of the matrix. This matrix is given to you. Then find, this is a square matrix, find trace, determinant, eigenvalue of H. So first we have to identify that it is a block diagonal matrix. Don't reduce it to this form. If it is in that form, apply. These two need not be square. They can be rectangle. We are interested only in A and B. If these two are square matrices, then only we can talk about trace, determinant, and eigenvalue. Now, what is our A? This is in the form A0, 0B, where A is 0, 1, 1, 0. BA 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. Now we want trace H. Trace of H is trace A plus trace B. What is trace A is sum of the diagonal elements. What is trace B is 1, 1, 1. 3. So trace H is 3. Next, det H. Det A into det B. Det A is AD minus BC. So where det A, AD minus B. Det B is 0 because two rows are equal, determinant is 0. So minus 1 into 0, which is 0. H is singular. Is H singular or not? Which of the following is true? H invertible, H is singular, like that. Hence, H is non-invertible. Because H inverse does not exist. Why it does not exist? It is singular. Why it is singular is determinant is 0. Now we want eigenvalue. So A is equal to 0, 1, 1, 0. What are eigenvalues of this? What are eigenvalues of this?
1 minus 1.
So we have to apply determinant A minus lambda is 0. Subtract lambda. So I thought somebody will say 1, 1. If it is like this diagonal, then 1, 1. But this is not diagonal. So be careful. Some of you may be tempted to write that. Plus or minus. So what are eigenvalues of A? Eigenvalues of A are minus 1, 1. This is lambda 1, lambda. Now B is nothing but 1, 1, 1, 1, 1, 1, 1, 1. So what are eigenvalues?
0, 0, 3, man.
Of B are 0, 0, 3. mu1, mu2, mu3. So what are eigenvalues of H? Eigenvalues of B union eigenvalues of H are, what are eigenvalues of A? Minus 1, 1, 0, 0, 3. So for this matrix, finding characteristic equation is difficult. For this matrix, finding characteristic equation is difficult. H is 0, 1, 1. For this big matrix, it is difficult to get characteristic equation. Applying determinant A minus lambda equal to 0, this is difficult. But easily we can find, provided both A and B are square matrix. For any higher order, try to split like. Check whether it is in this particular form or. If it is in this particular form, any number may be there. Just to simply apply these techniques and get the eigenvalue. And you can also get the characteristic equation. Characteristic equation of A into characteristic equation of B will be the characteristic equation of B. Okay. Any doubt? This is advantage. Advantage enti? Very big matrices, large matrices are there. Data science kotta subject vastundi kada. They use this matrix theory. One of the beautiful applications. So they apply total information, they keep in blocks and they play with the blocks. So they apply more of this block matrices because very big information is there. Then how do we drive that information? They use for their business purposes. Total business analytics and data science is based on this matrix theory. Okay? This is the advantage. Nowadays, new concepts are coming, you may get an application. So find the eigenvalues of this matrix. Then if you know the shortcut, easily you can do. Any doubts in this? Any doubt? No doubt.